All right, so we're going to start reviewing with this. There's a couple I'm going to do with you guys, and some of these I'm going to give you time to work individually, but I want to walk through the first couple together. I took a random sample of 5 students' heart rates. The sample mean, the average of those 5 students' heartbeats, was 64.5 beats per minute with a margin of error of 5.6 beats. Do you guys know what a margin of error is? Have you ever heard that before? So for those of you that aren't familiar with margin of error, and we will go into much more detail about margin of error next semester. This is just kind of the first time we've looked at it. When we take a sample, I don't expect that what I get from the sample is going to be like 100% exactly the same as my larger group. So that margin of error gives me a window for what would be expected or what would be typical. So as long as it falls within these amounts, and we take that margin of error, we add it and subtract it to get the upper and lower boundaries. So I kind of gave this one away. Would we expect the population mean to be exactly the same as the sample mean? No. Would we expect it to be close? If it's a well-selected sample, it should be close. All samples are different due to sampling variability. We don't expect the sample mean is exactly the same. Never thought about using that as a standing desk. It's supposed to be better for you too. So you're making healthy choices.
Yes, I lean as needed.
And now you're reminding me of my restaurant days. If you have time to lean, you have time to clean.
That's true. Yeah, that's true.
Would you be surprised to learn that the true population mean was 68 beats per minute? Would that be surprising? No. What would the window be? Let's look at that margin of error. What's the upper and lower boundaries for what would be expected? 70.1 for my upper boundary. 58.9 for the lower boundary. You take the mean from the sample, which was 64.5. You take the mean from the sample, 64.5. Where did it go? Right here. To get the upper bound, you add this to it. To get the lower bound, you take that number and you minus the margin of error. So you get the upper and lower boundary by taking that sample mean. You add onto it the margin of error to get this upper boundary, and you subtract the margin of error to get the lower boundary. So as long as the population mean is in between these two numbers, that would be expected. That wouldn't be surprising. How can I get a sample mean that is closer to the true population? Have a bigger sample. Increase the sample size. All right, they had us waiting all the way until here, until I gave you your beverage, but we got that out of the way already. Is this an experiment or an observational study? Ooh. Why? Treatments were assigned. Treatments were assigned. You guys did not get to come up and choose whether you wanted A or B. I told you whether you got A or B. Did we use blinding?
Yes.
Yes. How did I use blinding?
We don't know which was which.
Yeah, we don't know which was which, so this would be single blind because I do know.
Yes, ma'am.
Why is blinding important? We want to combat the placebo effect. So this next question, for starters, I'm not looking for examples. We'll get to examples in a minute. I just want to know, big idea, what is a confounding variable?
Other explanations.
Other explanations for what?
Result.
For the results. So this would be something that influences our results. It has to have some kind of a connection to our explanatory variable as well. There has to be a correlation or a relationship with the explanatory variable, and it's something that does influence the response variable, the results. Thinking about this situation here, what are some possible confounding variables? Kaylee, I'm thinking of what you said a minute ago.
Oh, me and drinking Mountain Dew.
So prior exposure to caffeine in the same day, right?
Literally not even 3 minutes ago.
What are some other possible things that could be confounding variables here that would affect? Blood pressure might absolutely affect this. What'd you say? Whether you consumed sugar before, because we know that sugar has an impact on heart rate. What else? Tolerance. What's your natural caffeine tolerance? Some people can drink coffee and then go right to sleep.
Yeah, I get sleepy.
So it doesn't, well, I don't feel like it increases my heart rate. Maybe it does. I've never sat down and like done my pulse before and after, but it's certainly not enough to keep me awake. What else might affect heart rate that has a connection with caffeine? Yes. Oh, scratching head, sorry. Do you think, yes?
Did you want to play any sports?
Yeah, like how athletic are you? That might have an effect on it. Do you think body size would have anything to do with it? I mean, everybody got the exact same amount, and I don't know, like I know that dosage for the same medication for children versus adults changes, and it's not because it's ineffective, it's because you want to make sure that you have the right level for that body size. So body size could be affecting this. Did anybody in here skip lunch? So you drank caffeine and skipped lunch. Ooh, you got 2 of them. Like what you have in your stomach beforehand would be affecting this. So some ideas, and you guys can tell what time of day I was working on this. These were just some of my thoughts here. Whether or not you had breakfast/lunch. Caffeine tolerance, physical activity level. We've mentioned most of these, and we mentioned even more. If we really just want to see if caffeine increases heart rate, why couldn't we have just given you all caffeinated drinks? We need a control group. Why do we need a control group? For comparison. We have to be able to have something to compare it to. I'm going to give you guys about 7 minutes on the next page. My preference is that you work with a partner or small group as you work on the next page. And actually, if you have time, I would like for you to get all the way to question number 16, which is actually at the top of the 3rd page. See if you can get all the way through the 2nd page. And if you have time, hop over and do number 16. Like I said, I'm going to give you about 7 minutes to work on this, and then we will come back together. Okay, correct button this time. I know you might not be all the way done with this page. That's okay. But we're going to kind of figure out where we are and walk through these pieces. What is the explanatory variable here? Caffeine/no caffeine. So either the presence or absence of caffeine. What is the response variable? Ooh, close. It is like we're almost there. Change in heart rate. Remember, we took our pulse at the beginning. we're going to take our pulse again. So it's not just do you have one or do you not have one, but it's how much is it changing with the presence of caffeine or the lack of caffeine. What do I mean by experimental units? Oh, if you just wrote heart rate? If you wrote heart rate, I would look at it as being partially correct. But specifically, we want to go after the change in the heart rate there. Good question. What do I mean by experimental units? Yeah. Who is being experimented on? Who are we experimenting on? This class. So all the students present in this class today. How many treatments did we have? 2 treatments. What were they? Yes, Diet Coke with caffeine, Diet Coke without caffeine. And please believe me, I looked for everything I could, like 2 different stores. After that, I gave up. I'm like, I'm not going to a 3rd store. The only ones that I could find where it matched up was the Diet Coke. All right, so how could we go about randomly assigning the students in this class into 2 groups? What would we want to start off by doing? Number, label, yes. So we're going to number each of the students with a number 1 to 21. Then what? Use a random number generator. I'm going to use RNG to abbreviate random number generator. What am I going to use my random number generator to do? I want about half. Can I get exactly half? Okay, so we have to make a decision. Are we going to go with 10 or 11? 11 sounds good. Use our random number generator to select 11 what? 11 unique numbers, yes. Okay, so I have my 11 unique numbers. What are we doing with those 11 unique numbers now? Assign the corresponding students. What are we going to assign them to do? To get caffeine? Okay. To get Diet Coke with caffeine. And anything else? Assign the remaining students to get no caffeine. Yes, thank you for talking to me about what everybody else does. That's the one thing that, like I've told you guys before, as I've graded AP questions, that's the thing that gets missed, and that'll take it from a beautiful, perfect, well-explained answer to a partially correct, because they leave out what happens to everybody else. Assign the rest of the students. Caffeine-free Diet Coke. Oh, I can just fit it in there. Good job. Okay. Why do we use random assignment to create the 2 groups? Sorry, I heard voices over here, but I couldn't tell what we were saying. To do what? We want to determine cause and effect. How does random assignment help us with that? What'd you say? Low bias, low variability. You had an idea earlier that I want to hear.
Combat confounding variables.
Helps us also combat confounding variables. Will I be able to eliminate the confounding variables? No, but I can make sure that they're equally sprinkled between my two groups, so that if there's somebody who's super athletic in one group, I probably get somebody who's super athletic in my other group. We want to create roughly equivalent groups to control for confounding variables so that we can establish cause and effect. It's not going to eliminate my confounding variables. Is this even a perfect way of dealing with confounding variables? No. But if I don't know what the potential confounding variables are, I can't control for them, so I go with random assignment. And we do this so we can establish cause and effect. All right. I think we're going to have time for one, maybe two more, but I want to pause right here and get our post-caffeine. Got to wait just another minute, I think. Right? No, never mind. We'll do it right now. Find your pulse. Everybody found it? Ready, set, go. Stop. Take your number times 4. You're going to write this down. Number 17. Oops, I went a little too far. Right here, number 17. Write down what your heart rate is now, so whatever you got times 4. And then what I want you to do is that new one that you just took, I want you to do that minus whatever your original was. And write that down on this line right here. So whatever your original was, minus this one.
I just wrote that one not to learn.
Oh no.
Because
Okay.
I checked here, I couldn't find it, and then I checked here, I couldn't find it, but then the time was out, and I found it.
When you found it? Okay. Well, we could probably get a baseline tomorrow at the beginning of class, as long as you have one for right now. So take whatever you got from right now, multiply it by 4 so that you have your beats per minute. All right. We have just enough time that we can lay out a completely randomized design, and then we'll finish up the rest of this tomorrow. How can we lay out a completely randomized design here? 21 students is what we start with. And then what? 2 groups. How do I get my 2 groups? Random assignment. So random assignment next. Which I'm not going to go through and explain here because we already wrote down how we would do that random assignment. Okay, so then we have 2 groups. What should I call my 2 groups? Group 1 and group 2. What should we do with group 1? All right. Caffeinated Diet Coke. And group 2, caffeine-free Diet Coke. Okay, now what? Compare. What are we comparing? Comparing the change in heart rate. Nice. Nice, nice, nice. Okay, we will finish this tomorrow. Since you guys have already taken your post-pulse, I'll go ahead and let you know my group A, the first group to come up, you were my caffeine group. Group B was caffeine-free.